Welcome back to Around the World in 80 Telescope. This is a 24-hour live webcast. This is part of the 100 Hours of Astronomy. So you are joining us from the European Southern Observatory headquarters near Munich. I am Olivier Henault and I will be your host for the next few observatories. So now we're going to go to space. We are going to the Stereo mission. Hello, we are now going to speak to our stereo scientist. Sorry for the false alarm and the earlier attempt of connecting you. So, can you tell us who you are and what are you doing? What are you doing at Stereo?
Yes, my name is Alex Young, and I'm a scientist with the Stereo project at NASA's Goddard Space Flight Center. And in particular, my work centers around studying these coronal mass ejections, or CMEs. I'm very interested in trying to come up with better ways to track these and to look at the dynamics, how fast they're going, how big are they, and ultimately this is to lead us to the ability to predict when they're going to occur and have an understanding of what sort of effect they're going to have on the Earth if they impact the Earth.
Looking at the video, they are really big. It's really impressive. Could you tell us how big is big?
They're incredibly big. So they start off many times the size of the Earth when they leave the Sun, but they're traveling very fast and they're also expanding. And so by the time they reach the Earth, their extent is almost the extent of the distance between the Earth and the Sun itself. So many millions of kilometers in size. Just an unbelievable scale, something that we're just not used to in our everyday life.
Indeed, it's really big. Now, a striking feature of your satellite is actually you have two. So why two spacecrafts?
Well, the previous mission that we had, SOHO, the Solar Heliospheric Observatory, did very similar work that Stereo did, but SOHO sat right between the Earth and the Sun, and so when one of these CMEs traveled towards us, it's very difficult to see how fast it's going. So you can imagine if you're looking at someone and they throw a ball at you, it's very difficult to see how fast that ball is traveling as it moves towards you. But if you're standing on either side of that ball, it's much easier to figure out and to estimate its speed. So the idea with Stereo is that we go from this single or monocular view to more of a binocular or stereoscopic view. So you now move out to either side of the Earth, and so when one of these CMEs travels towards you, you have two side views of it. And so this allows us to see much better how fast it's traveling, and also we really want to know what is the structure, what do these things look like, and when they're traveling towards us, how do they expand? Because we want to know if that's going to tell us something about how terrible these things are going to be. So is it going to interact with the Earth and cause all of these electrical disturbances that were discussed earlier, which we call space weather? So Stereo is something incredibly unique. It's given us a view that we've never had before.
So which kind of disturbance have you really observed? Is there something that people would remember that was caused by space weather?
Well, many people, I'm sure, have seen the northern lights or the southern lights, the Aurora Borealis. And so this is actually a phenomena that we see on Earth that is a result of one of these space weather events. So when these large blobs of hot solar plasma travel towards the Earth and impact the Earth, they can actually cause the Earth's magnetic field to ring, sort of like a bell. And one of the things that happens is that the end of the Earth's magnetic field, so the Earth's magnetic field is stretched out, and we call that the the end of it, the magnetotail. And there are a lot of particles that collect there. And so when this magnetic field sort of rings like a bell, occasionally this tail can pop and send particles traveling down the tail into the polar regions, either the North Pole or the South Pole. And these streaming particles excite gases in the atmosphere. And we see these in the form of bright reds and bright greens, and that's the Aurora Borealis. So that's actually a very beautiful aspect of space weather.
And since the launch of the mission, since the beginning of the mission, have you seen a really big storm? Could you really test your equipment in the worst case situation?
Well, we've seen a few large coronal mass ejections, but unfortunately we haven't seen very many. The problem is that right now the sun is close to what we call solar minimum. So the sun has a cycle of activity. So roughly every 11 years we go from very little activity, and this corresponds to times when there are very little sunspots, to very high activity when there are a lot of sunspots. And the CMEs are associated with these sunspots. And so, unfortunately for us right now, we're at a very low level of activity.
Well, I wish...
But we have had an opportunity to see a few CMEs. We haven't seen very many of them. But, actually one aspect of this that's not so bad is that during times of lots of activity, there are many CMEs happening all at the same time. And they get very confused. They interact with each other, and the process is much more complicated. So to some degree, looking at a CME when it's not very active at the sun, you're able to, say, watch one event and see it in much more detail. So we have been able to understand a lot more about these CMEs, and we're looking forward to the increase in activity so we can see more of them.
Well, I really wish you some nice storms. And have you had any surprises, any unexpected results from the mission?
Well, one of the things that we saw that actually is a combination of CMEs and comet physics. There was an image that was that hopefully they'll be able to show, and this is an image from one of the instruments on. Here we go. This is an image. So you see, there's this little tiny comet towards the bottom of the picture, and what happens is the CME is traveling along, and it actually breaks the comet's tail off. And this is something that's quite exciting, both for scientists studying CMEs and scientists who are studying comets, and not necessarily one of the main goals of stereo.
That's totally spectacular. I work myself on Comet, so this is really exciting.
It's an amazing picture, isn't it?
Yes, spectacular. So, and these images of a comet grazing the sun, you have that in 3 dimensions, in stereo too?
I'm actually not positive if any grazing comets have been seen in both instruments in stereo. I don't believe that they have. Hopefully that's something that we'll see soon. One of the problems with that is that right now the stereo spacecraft are moving around the sun, and so as they move farther and farther away, we have less of a chance of seeing 2 exact fields of view. But hopefully we will see some of these grazing comets in a 3-dimensional perspective soon.
That would be fantastic. Okay, so the sun in details, the coronal mass ejections, comets, is there anything else that you can see with all the telescopes that you have on board?
Well, one of the other goals of stereo is actually to look at the solar wind. So, the sun has this outer corona, this outer atmosphere that's very hot, many millions of degrees. And because of that, because energy is constantly being pumped into this atmosphere, particles stream away. And we call that the solar wind. And so one of the things that we want to do with stereo is to actually be able to model this solar wind in 3 dimensions. And so now that we're able to look at the solar wind from different viewpoints, so we can look at the origins of the solar wind on the sun's disk, and then we can see when those solar wind disturbances will reach different spacecraft, the stereo, as we call, ahead, or the stereo behind. And so this is giving us an opportunity to see three-dimensional structure in the solar wind. So that's one of the other major goals of the stereo project.
Great. Listen, I get a question from one of our viewers, Beck, who is asking how students can be involved in this kind of research. So what would you say to a student who wants to come and work with you?
Well, my suggestion would be for students to send a message to one of the webmasters on the Stereo website. Also, NASA has several student programs, and so if you go to NASA and do a search on student summer programs, for example, then students can apply and come to NASA and do research. And there are also lots of projects on the web through our education public outreach that students can do at their home institutions. And I personally work with a lot of students in the summertime, and there are all sorts of different exciting research projects that one can do. So I would say the best thing for students to do would be to go to www.nasa.gov under the education section and look for some of these programs.
Okay, thank you, Alex. Thanks a lot for your time and for telling all these about the stereo mission. So you are watching around the world in 80 telescopes. So please stay with us for our tour of telescopes on the planet and around the planet. Next one in a few minutes.